Hi students, today I am going to explain what is hybridization rules. When we make hybridization, what are the rules we have to remember. So what are the rules governed for hybridization of atomic orbitals? So the orbitals of only similar energies of same atom can mix to form hybrid orbitals. When we mix the dissimilar energies, so what happens? Their nature we cannot predict. So we cannot determine the hybrid orbitals, their nature. And we may mix a certain number of orbitals as per our requirement. Maybe 1s with 1p, or 1s with 2p sp2, or 1s with 3p sp3 hybrid orbitals, or 1s with 3p and 1d sp3d hybrid orbitals, sp2d2 hybrid orbitals, like this. So we can mix certain number of orbitals as per our requirement, and the number of orbitals, atomic orbitals, we are mixed together equal to the number of hybrid orbitals are formed. So how many atomic orbitals we mix, that many hybrid orbitals it will be forming, and all the hybrid orbitals will not be in identical shape. They will be differ in their orientation, but they are similar. So and once a hybrid orbital is formed, it is no longer available to hold electrons in its pure form. So before in the ground state, how it will be? It will not be available in the ground state. After it get excited and after the mixing of hybrid orbitals, it will be in the excited state only in that, and we cannot see it in its pure form. So these are the rules. So very easy, only similar energy of a hybrid orbitals will mix, and in the process of mixing of single atom or ion is not like molecular orbital formation, and we can mix a certain number of orbitals as per our requirement, and equal number of hybrid orbitals are formed. How many atomic orbitals are there? That much hybrid orbitals are formed, and they may not be similar. They may not have identical shape or orientation. That's all. So next we will see how the formation of BeCl2 molecule is forming. So Be is beryllium chloride molecule. So beryllium is a central atom here, and its electronic configuration is 1s2 because its atomic number is 4. So no unpaired electrons are seen here. So in the ground state, so it cannot form bond in the ground state, but after excited state is formed. So the 2s electron will go to the 1 electron will go into the 2p. So 1s2, 2s1, 2p1. So 2 unpaired electrons are available. So it can form 2 bonds with chlorine. So here BeCl2 molecule formation is possible. So in this, the 1s orbital and 1p orbital will get mixed up to form 2 sp hybrid orbitals, and the energy of hybrid orbitals will be becoming more. In the ground state it will be less. After in the excited state it will become still more, and the hybridized state more will be there. Energy will be more. So here the what type of hybridization we can see. What type of hybridization? sp hybrid orbitals are formed. So sp hybridization, because there are two types of overlapping here, sp and pp, and both the bonds are identical, and we can see a linear molecule is forming. So BeCl2. So 2 sp hybrid orbitals reacting with 2 chlorine atoms. So here one this side and this side 2 sp hybrid orbitals are formed. BeCl2, like this linear molecule is formed. Then BCl3 molecule, boron. Its central atom is boron, and its atomic number is 5, and its electronic configuration is 1s2, 2s2, 2p1. 1 unpaired electron is there. So it can easily form BCl in its ground state, but in excited state again this S will give 1 electron to the P. So 1s2, 2s1, 2p1, 2px1, 2py1. So 3 unpaired electrons are there. So it can easily form BCl3 molecules. 3 electrons it will share. It will share to form BCl3 molecules. So here what type of overlap we can see? 2 types of overlap, sp and pp overlap. So 1 s and 2 p's are involved in it. So it is a sp2 hybridization, and we can see here. So 3 chlorine molecules with one central B. So it will form BCl3 molecules, and hybrid orbitals will have high energy. And so we can see here its a shape is triangular shape. Then CH4 molecule, methane. Let's see the formation of CH4 methane molecule. The center atom is here carbon. So as we know, its atomic number is 6 and its electronic configuration is 1s2, 2s2 and 2p2. So in the ground state we can see here 2p2 means 2px1 y1. So 2 unpaired electrons are there. So it can form CH2 molecule. So but when it gets excited, so what happens? This S molecule, S shell, it will give the electrons to P. So 2s1, 2px1, 2py1, 2pz1, 4 unpaired electrons are formed. So it can share with 4 hydrogen molecules. Here 1s and 3p hybrid orbitals are formed. So sp3 hybridization. So sp3 hybridization, these hybrid orbitals will have high energy. 4 CH bonds are formed and it have tetrahedral structure, and it will have same strength, and the bond angle will be 109 degrees 28 minutes. So like this we can explain the CH4 molecule very easily. And last is nickel NiCN4 2 minus ion. The central atom is nickel. Its atomic number is 28. So we write the electronic configuration. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d8, 4s2, 4p0. So I will write it in like this. So the outermost shell 3d8, 4s2, 4p0. So 3d8, 2 free cells. So valency cells are there. Valency electrons are there. So here 4s2, it is completely filled. After that it will give 2 electrons. So nickel 2 plus, these 2 electrons will be given to form 2 plus. So same will be there. It will be free. So after that it will react with CN4. So cyanide with 4 to form 4 shells. So 4 sharing here and these 2. So what is happening? 1s, 2p and 1, 3. So sp2 dehybridization is formed. So square planar geometry, it is NiCN4 2 minus. So it like this we can explain the NiCN4 2 minus geometry. Thank you.